Most people have no idea that right now, two spacecraft are drifting through interstellar space, more than 15 billion miles from Earth, transmitting data back to us using a power source with zero moving parts, zero fuel, and zero maintenance. They have been doing this continuously since 1977, nearly 50 years of uninterrupted electricity generation from nothing but a temperature difference. And the physics behind it costs $15 to replicate. That is not an exaggeration. That is exactly what we are going to build today. Before we get into this, if you are new here, this channel is about the knowledge most people never learn until they actually need it. Hit subscribe so you do not miss what is coming next. I want to start with the moment this clicked for me, because it changes the way you look at energy permanently. I was deep in research on off-grid water systems, completely unrelated topic, and I fell down a rabbit hole that led me to a German physicist, a principle discovered in 1821, and a realization that stopped me cold. The heat you are already producing from a fire, from an engine, from a camp stove, from a compost pile. That heat is electricity you are throwing away every single time, not metaphorically, literally. The energy is there. The physics to capture it has been understood for 2 centuries, and nobody in the energy industry has ever had a reason to tell you about it, because there is no money in a $15 solution. Here is the history, and it matters, because understanding where this comes from tells you exactly how reliable it is. In 1821, a German physicist named Thomas Seebeck was experimenting with conductive materials. He discovered something that seemed almost too simple to be real. When you join 2 different conductive materials and create a temperature difference between them, one side hot, one side cold, voltage appears across the junction. No chemical reaction, no combustion, no moving parts of any kind, just a temperature difference, and electricity flows. The bigger the gap between the hot side and the cold side, the more electricity you get. Seebeck published it. The scientific community understood it. And then, because cheap coal-powered electricity was easier and more profitable to scale, the principle sat on a shelf for 100 years. Then 2 things happened that proved exactly how serious this technology really is. The Soviet Union needed to power more than 1,000 unmanned lighthouses and navigation beacons along the Arctic coast. There was no electrical grid out there. There was nobody available to refuel anything. So they built thermoelectric generators using the Seebeck effect, paired with a radioactive heat source. Set it, leave it, come back in a decade. Over 1,000 of these generators were deployed along the Arctic coast by the late 1980s, running without a single person touching them. At almost the same time, NASA needed to power spacecraft heading to the outer solar system, where the sun is so far away that solar panels are completely useless. Voyager 1 and Voyager 2 each carried 3 thermoelectric generators, 470 watts at launch. Today, nearly 50 years later, each probe is still generating around 220 watts, 0 moving parts, 0 maintenance, a temperature difference, and the same physics Seebeck wrote down in 1821, still powering spacecraft at the edge of the known universe right now. So why have you never heard of this? Because the 20th century was built around a centralized electrical grid, and once that grid was in place, utility companies had every incentive to keep you dependent on it. The thermoelectric effect stayed alive inside NASA programs and military applications, but it never made it to your hardware store. Not because it does not work, because it works too well on its own. The average American household pays around 16 cents per kilowatt hour according to the U.S. Energy Information Administration. The actual cost to generate that power is a fraction of that number. That gap funds an infrastructure you do not own and an industry with no motivation to tell you that the heat coming off your wood stove right now is electricity going straight into the air. The component you need is called a TEG module. TEG stands for Thermoelectric Generator. The most common one used in DIY applications is the TQ1-12706. You can find it on Amazon or AliExpress for around $8. It is a small ceramic and metal tile, roughly the size of a large postage stamp and about as thick as 4 credit cards stacked on top of each other. Inside are 127 pairs of semiconductor elements made from bismuth telluride, the same material family Seebeck was experimenting with 2 centuries ago. The principle of operation is exactly what Seebeck described. Hot side on the bottom, cold side on top, temperature difference produces electricity. At a temperature difference of around 60 degrees Celsius between the two faces, which the surface of a wood stove achieves easily, the module produces approximately 3 volts. That is not quite enough to charge a phone directly, so you add one more component, a DC to DC USB voltage booster, available for around $5, takes that low voltage output and steps it up to a clean 5-volt USB output. Connect the TG module to the booster. Plug your phone cable into the booster. You are now charging your phone from firewood. Total cost, $15. The stove was already burning. You were already throwing every bit of that heat away. To get the most out of the setup, there are a few details worth doing right. Place the TEG module flat on the stove surface with a thin layer of thermal paste between the module and the metal, the same compound used between a computer processor and its cooling system, designed specifically to maximize heat transfer across two surfaces. On the top face of the module, attach a small aluminum heatsink to keep that surface as cool as possible. Remember, the system runs on the difference between the two sides. The hotter the bottom and the cooler the top, the more voltage you generate. Even a light breeze moving across the heatsink makes a measurable difference in output. If you want more power, wire 2 or 3 modules together. 2 modules running simultaneously can charge a phone faster and power a small LED light at the same time. Now here is where this goes from a clever experiment to a genuine off-grid power strategy. Consider what happens when you scale this up even modestly. 8 TEG tiles, a higher quality booster circuit, and a small sealed battery bank to store the output. That setup costs somewhere around $200 total and can be mounted directly on the flue pipe of a wood stove. Anytime there is a fire going, the system runs. It powers LED lighting throughout a cabin, keeps a phone and a radio fully charged, and trickle charges a battery bank large enough to run a small water pump. And the stove was already there. The firewood was already burning. The only change is that you stop throwing the energy into the air. Beyond the wood stove, once you understand the physics, you start seeing usable heat sources everywhere. In a vehicle, van, truck, overlanding rig, a TEG module mounted against the exhaust housing or near the firewall generates electricity anytime the engine is running. It will not replace your alternator, but it silently supplements your battery bank for every mile you drive, with nothing to maintain and nothing to point at the sun. At a campsite, a single module and a booster fits in a jacket pocket. Set it on the edge of a camp stove, prop the heatsink side up for airflow, and you have a phone charger running on whatever fuel you're already cooking over. No battery pack to remember. No searching for a solar angle in a shaded forest site. In a remote hunting or fishing cabin with a propane heater or a small wood stove, a $50 TEG setup keeps radios, GPS units, and headlamps charged for an entire season without hauling batteries in or running a generator. On a sailboat or small power boat, a module array near the diesel exhaust line generates supplemental power anytime the engine runs, genuinely useful on longer passages when solar input is limited by weather, season, or the shadow of the rig falling across your panels. And then there is one application that surprises almost everyone the first time they hear it. An active compost pile in full biological decomposition reaches internal temperatures between 55 and 70 degrees Celsius. The outer surface of the pile stays cooler. That is a real, stable, measurable temperature difference you can harvest. A TEG module at the interface between the hot interior and the cooler outer layer with leads running to a small booster can power a soil moisture sensor, a garden timer, or a small light, off nothing but the biological heat of rotting plant material. No burning, no fuel, no sunlight. Just biology doing what biology does, and you catching the energy on the way out. None of this replaces a utility connection. One module will not run a refrigerator, and stating otherwise would be dishonest. What it does is make something undeniable that the energy industry has never had a reason to say out loud. The waste heat you are already producing from equipment you already own, using physics that has been understood for 200 years, can be turned into usable electricity for $15. And once that idea is in your head, you cannot stop seeing heat sources. The wood stove, the camp stove, the engine block, the exhaust pipe, the compost pile. Every one of them is a power source you have been walking past. The Voyager probes are 15 billion miles from Earth right now. They are still sending data home. They run on a temperature difference, the same principle, the same physics that a German physicist named Thomas Seebeck wrote down in 1821. You can build your first version before the end of this week for the cost of a fast food meal. The parts are on Amazon. The physics is 2 centuries old. The only thing that was missing was someone telling you it was possible. Now you know. Stay prepared. Now you know. If this is the kind of knowledge you want more of, subscribe and leave a comment telling me what heat source you are going to use first. I read every single one. Stay prepared, and I will see you in the next one.